good evening. Is that my voice is clear?
Yes, sir.
Yes, sir.
Okay, good. Okay. So if you have any doubt in last class, then you can ask me. Otherwise, I will go for next level of this calculation and discussion of particle in box. Today, at least, we will finish the all theory part of this box part. Okay. So let us go for next level, and then we can discuss each and everything. Same thing will come again and again. Don't worry about this. Okay. So okay. So in last class, we have solved the box part, that is infinite box, and we just confine our particle inside this box, and we have solved the eigenvalue and eigenvectors. What we get? We get there is discrete eigenvalue, and that eigenvalue is proportional to n square actually, and you can get En is n square E naught, where n can be 1, 2, 3, and so on. We also discuss why n cannot be 0, and there is energy level which are discrete, which are not possible for the uh, classical case. In classical case, we have all possible values of energy, but in quantum mechanics, yes, there is discrete part, and yes, this discreteness will come when we have bounded system, because you remember that when my particle was free, that is not bounded, they can extend it up to minus infinity to plus infinity, then you can you have seen that the energy eigenvalue will be continuous. But as we have confined this thing, and then we have found that discreteness will come into picture. So now I am again going to solve the same problem, and we are just making the same story. But right now I will just shift the box little bit, and I am just going to shift the or box a little bit towards left. Let's see what is going to happen and how parity will come into picture. And parity is one of the very important operator to understand the symmetry of a system. So let's try to see the symmetry, and we will solve again the particle in infinite box. But right now, my potential Vx is written as 0, where x is between minus a by 2 to plus a by 2, and infinite otherwise. So what we have this is our infinite potential. So the width is same, but what we have done, we have shift the coordinate. This is all about minus a by 2. This is all about plus a by 2. And this is all about 0. So this is infinity. This is infinity. So what we have done, we have shift the potential from 0 to a2 minus a by 2 to plus a by 2. And you can see this beautiful potential is symmetric about x is equal to 0. What is the meaning of symmetric about x is equal to 0? You can mathematically you can say v minus x is equal to vx. So the nature is exactly same. Either you will move towards right or towards left. So my potential is symmetric, and it is observed in the nature that when potential is symmetric, then your parity must be conserved. This is the observation. So obviously we have done the classical mechanics. If something is going to conserve, then obviously we can easily say pi and h is going to commute. You remember from all the part we have discussed in the classical mechanics that you can just say df upon dt is equal to f h plus del f upon del t. So if df, and suppose del f upon del t is 0, then df upon dt is 0 if this is going to commute. So same thing is also there. So there is a commutator part. I have told you about this commutation. This is the same thing what we have discussed into the Poisson bracket. So yes, the parity and Hamiltonian is going to commute. What is meaning of that? Meaning of that, what should be the eigenfunction of Hamiltonian, that should also the eigenfunction of parity. So we have to use this constraint. These are the one restrictions. And what are the parity? The parity is the very interesting operator. It has pi psi x is equal to psi minus x is equal to psi x. Then you have eigenvalue 1. And similarly, pi psi x is equal to psi minus x is can be written minus psi x. Then you have eigenvalue minus 1. This is all about known as even parity, and this is all about known as odd parity. Even parity is all about symmetric. Our wave function must be symmetric. This will tell you about the symmetric, and this will tell about the antisymmetric. We will discuss all about symmetric and antisymmetric case. So what should be the eigenvalue of parity? The eigenvalue of parity should be either plus 1 or minus 1. So if we are going to solve the Schrodinger wave equation, we can solve it. Yes, we can solve this differential equation. We can solve this particular Schrodinger wave equation. And after the solution, we must check that wave function must be either symmetric or antisymmetric. Because we have seen in the nature that when your potential is symmetric, then parity must conserve. Let's do this exercise very nicely. The solution of Schrodinger wave equation is exactly same. There is not going to change, but yes, extra constraint or extra information is there, and we must use that extra information to analyze our system. Right now, if you have any doubt, you can just ask me. Then I will just go for the next mathematical part.
In this example, we are just changing the shifting the origin, right, from the place.
Yes, yes, yes,
So then
yes,
how is
yes,
it
yes.
affecting and how is it changing the thing?
That is the thing. That is the thing. That is the thing. That is our main agenda of today's class, isn't it?
Okay, sir.
Okay. So
Sir,
yes,
sir, last day also we had the same sort of potential, but only the range was
that is
different.
exactly same potential. There is not any
Yes, sir.
problem.
Sir,
Not any problem.
sir, I
Yes.
cannot understand that why today this is symmetric and last day it was not symmetric potential. Can you please
Because
explain?
I have shift the middle point, because it is symmetric. It's all about your reference. Where are you standing? Where is your origin? And from this
Okay, sir.
origin, how thing is there, that will tell about the symmetry, isn't it?
Okay, sir. Yes, sir.
And you will see the basic physics will remain same. Don't worry. But mathematical interpretation can be changed. That is the ultimate thing will come after the conclusion. So hence you are in little bit that uh, questioning mode, and then so why I have tell you the final conclusion. So let us try to solve it, then we will find out the final conclusion. Okay.
Yes, sir.
Okay. Okay. So let's try to figure it out. So obviously this is region 1, this is region 2, this is region 3. So region 1 psi 1 is 0, we all know, minus a by 2. Psi 2 is all about a e to the power ikx plus b e to the power minus ikx. X is between minus a by 2 to plus a by 2, and psi 3 is equal to again 0. X is greater than a by 2. This is the beautiful expression. Particle is free inside this box, so that is the only solution. Now what is the next thing? So first I will discuss for the even parity. What is meaning of even? And obviously psi 1 and for the psi 1 and psi 3 there is nothing to do anything, because this is 0, and 0 you can treat even and odd. So There is not any problem. What is the problem in this particular? What will be the problem in this particular thing? The change is sign is always in this particular region. Here it is always negative. Here it is always positive. So there is not any problem. So what is meaning of even parity? Psi 2 minus x must be equal to psi 2x. So if this is even, then this have to followed. Then from this particular stuff, what I can say a e to the power ikx plus b e to the power minus ikx must be equal to a to the power minus ikx. Minus sign is there, then this is minus, this is plus, this will be plus, and b e to the power minus ikx. So what should be the conclusion? What should be conclusion? The conclusion is a is equal to b, isn't it? You will just equate
A is equals to
a
B.
equal to b. You can equate the e to the power minus ikx on both sides. Then only this solution is there. So if it is even parity, then a must be equal to b. Then my psi 2 is all about a e to the power ikx plus b, sorry, plus a will be outside, e to the power minus ikx. I can write this whole stuff as c cos kx. Can I write it? Yes. The mathematics is ultra beautiful. Ultra beautiful. Just feel this mathematics. And now, obviously, either you can check at minus a by 2. Hence, potential is symmetric. The behavior at minus a by 2 or a by 2 will be same. So what I can do, I can use the boundary condition. Psi 2 at a by 2 must be equal to 0. So if psi 2 at a by 2 must be equal to 0, then c cos ka by 2 must be equal to 0. Then what should be the ka? And c cannot be 0. Then ka by 2 must be equal to pi by 2, 3 pi by 2, and so on. So what should be the value of k? The value of k for the even parity can be, you can write pi by a or 3 pi by a or 5 pi by a. So what I can write the value of k can be n pi by a, and that n can be written as 1, 3, 5, and so on. So you can make a conclusion. So please try to remember it. So if the value of n is odd, if the value of n is odd, then parity is even. If the value of n is odd, then parity is even. And you can also get the energy, and that energy is En is equal to, you can find that will be n square pi square h cut square upon 2ma square, where n will be 1, 3, 5, and so on. You can easily find the energy. How you will get the energy? E is equal to px square upon 2m. And what is px? H cut k, isn't it? Px is h cut k. So you will write n square pi square h cut square 2m a square. But now n is 135 only for the even parity. And now we can normalize this particular thing and we can get the value of c. When you are going to normalize this thing, then obviously we will go to 0 to a, and this will be mod c square cos square n pi x upon a dx must be equal to 1. You can easily get this c is equal to again root 2 by a. So this is the all story of even parity. So if you have any doubt, you can just easily ask me. So why I have keep each and everything on the board such that you can easily raise the question. Yes.
सर ये इंटीग्रेशन 0 to a और minus a by 2 plus a by
Oh, sorry. Good. That is zero. Good. Thank you. That will be minus a by 2 to a by 2. Okay, good. दिमाग कहीं और है. That will be minus a by 2 to a by 2. Sorry. Thank you. Okay, minus a by 2 to a by 2. Okay, so this is the story of even parity. Let's try to figure it out. The story for odd parity. Then we will analyze the two things together, and it should be very interesting. Now, so for the odd parity, so you have to write psi 2 minus x must be equal to psi 2x. And now we can write a e to the power minus ikx plus b e to the power ikx must be equal to
Sir,
minus
minus
a.
सर माइनस आएगा ना ऑड पैरिटी में.
That will be minus. Okay, yes, minus. So minus a to the power ikx minus b to the power minus ikx. So what will happen? What should be conclusion? A is equal to minus b.
minus.
A is equal to minus b. Then what should be psi 2? Then psi 2 is equal to a e to the power ikx minus e to the power minus ikx. And now this can be written, let's say some d sine kx. And again, we will use the boundary condition. When you are going to use the boundary condition, you will write d sine ka by 2 must be equal to 0. Why? Because wave function must be continuous. Okay, you can take minus a by 2, there is not any problem. D cannot be 0, then we can write ka by 2 must be equal to pi. We cannot take 0 because if we will take 0, the whole function is 0. So k by 2 must be pi. That will be 2 pi and 3 pi and so on. So what is value of k? 2 pi by a, 4 pi by a, 6 pi by a, and so on. So k can be written as n pi by a, where n is equal to 2, 4, 6, and so on. So what we have concluded that when the value of n is even, then we will get the odd parity. And again, we can normalize it from minus a by 2 to plus a by 2. And that will be, you can take mod d square, that will be sine square n pi x upon a dx must be equal to 1. Then d will again get root 2 by a. And what should be the energy? The energy is again same formula we are going to use, but right now n will be 2, 4, 6, and so on. So energy is same thing, don't worry. En is equal to, for even parity, n square pi square h cut square upon, sorry, for odd parity, what is n? N is equal to 2, 4, 6, and so on. So this is the story of odd parity, isn't it? So this is a sine function. And now what I will do, I will just compare the two potential and we will discuss the physics. What is going to change, what is not going to change, how mathematics is changed or how physics is changed. Let's try to discuss. If you have any doubt, you can just ask me. Okay. Okay. So let me write each and everything and then we will discuss. First, whatever we have done into last class. Second, whatever we are going to use at today, and we will just compare each and everything. It's a beautiful comparison. Let's see. So my first question is, my first potential is something like this. I will take 0 to a, and now this is one of the beautiful point. This is all about a by 2. So this is again 0 to a. I will take something a by 2. Here I will plot phi. Here I will plot wave function. Here I will plot probability density. What is the solution here? The solution is h phi n is equal to n square e naught phi n, where n will be 1, 2, 3, and so on. And what is phi n? The phi n is root 2 by a sine n pi x upon a for x is between 0 to a and e naught and 0 otherwise. This is solution for this particular thing. Now let us try to write go for this particular thing. Minus a by 2 to plus a by 2. This is about 0. And minus a by 2, a by 2, this is all about 0. This is centered at 0. And what should be solution? I am using the same thing. So we have h phi n is equal to again n square e naught phi n. But now this n can be 1, 2, 3, and so on. Don't worry. But what is phi n? The phi n is equal to root 2 by a cos n pi x upon a for x is between minus a by 2 and a by 2 for n is equal to 135, and this will be root 2 by a sine n pi x upon a. Again I am talking about minus a by 2 to plus a by 2, and this is for n is equal to 2, 4, 6. Okay, so this is for n is equal to 2, 4, 6, and otherwise it is 0. So this is the story. Let's see what it reveals. So what will be the ground state energy? The ground state energy is E naught. And what will be the phi 1? The phi 1 will be something like this. And that will be written as 2 by a sine pi x by a. And what should be the probability density? That will be, here I am plotting the probability density. This is something like this. And this is also E naught. And this will be, again, you have 2 by a sine square, and not n, this is pi x, sine square pi x by a. you can write 2 by a sine square pi x by a. And if I am going for the first excited state, this is 4 e naught, and this value is something like this. This is eigenfunction. And if you will write, this value is something 2 by a sine 2 pi x upon a. And here, if you are going for probability density, it means mod psi square, this will be something like this. And this value is 2 by a sine square 2 pi x upon a. The value is 4 e naught. This is the symmetric representation. Then you can go for 3, 4, 5, and so on. Just we will compare two and then we can generalize it. Let's try to come for this particular system. What is your ground state? The ground state is again something like this. So I will make it little bit beautifully such that so this is all about your ground state. And what is its function is basically 2 by a cos pi x by a. And what is energy eigenvalue is E naught because n is equal to 1. And if you will just draw the probability density, this will be something like this. And you will get 2 by a, sorry, you will get 2 by a cos square pi x upon a. What is first excited state? The first excited state is something like this. And this is energy 4 E naught. And this value is equal to 2 by a sine 2 pi x upon a. And here we can just go for this particular thing. And what will be probability density? 2 by a sine square 2 pi x upon a. The energy is 4 E naught. So now you can see the whole story. Please, if I will tell you all about the physical measurement, what are the physical measurement? The physical measurement is energy eigenvalue. And you can see in the both potential, the energy eigenvalue is same. The ground state is E naught. The ground state is E naught. You can see. The first excited state is 4 E naught. The first excited state is 4 E naught. And if you will see the distribution of probability density is also same. Suppose some people who does not know what is mathematical thing and they did not know what is mathematics, and if I will show to him this figure and this figure, he will tell the figure is exactly same, because this thing is the physical quantity, the probability density and energy eigenvalue. This thing is just abstract. So for the general people, for the general measurement, if you will going to compare this one and this one, he will say this is exactly same. Because you can see in the ground state, this is maximum at a by 2, and that is center. That is center of the box. And here also the maximum is at the center of the box. What will happen when you will calculate the expectation value of x? In this case, you can easily calculate the expectation value of x is equal to a by 2 in this case for any energy eigenvalue. And here you will calculate the expectation value of x on any energy eigenvalue is 0. How you can calculate? This is very simple stuff. You can just take phi n star x phi n dx 0 to a, and you will get a by 2 in this case, and in this case obviously this will be 0, and this will be exactly 0 in this case. So what will happen? You can see if I am going to the first excited state, the minimum probability at the center, whatever be the coordinate of center, there is not a problem. So what is going to happen? The physical measurable quantity is same, but what is going to change is representation of state. And yes, if you will see this thing with respect to origin, with respect to center, then you can say this is the symmetric wave and this is antisymmetric. So what you can see, that ground state is always symmetric and first excited state is always antisymmetric with respect to center of the box, and which is nothing but the expectation value of x. So what will happen if you will keep your parameter fixed, means your box width is same, and you are just translating it horizontally? What is going to change? The wave function is going to change, but energy eigenvalue will remain same. And wave function will not change arbitrarily. Wave function will change such that it will remain symmetric for n is equal to 1, 3, 5, or n is odd, and it will remain antisymmetric for n is equal to even or 2, 4, 6, and so on. So it's a beautiful thing that there is not, the physics is not going to change. Physics will remain same. What is going to change is all about the representation of a wave function. Yes, it's a mathematical compulsion. It's a mathematical compulsion such that should be justify our physics. Yes, physics is always same. What will be the area under the curve? The area under curve is 1 because it is normalized. So what will be, if I will ask you what will be probability that particle will find between 0 to a by 2, you will surely tell 50% because this is symmetric. This is symmetric. The probability density is exactly symmetric about center. And even if in this particular thing I can say what will be probability that will be find particle between edge to center, then you will again say this area and this area will same. You can easily go and calculate thing. Here it is function of sine and here it is function of cos, but there is not any problem inside the physics. This is ultimate thing. And what is going to change is the only wave function. And wave function is also going to change with respect to keeping itself symmetric or antisymmetric with respect to center. If you have any doubt, you can just ask me.
Excuse me, sir.
Yes.
Sir, in third graph above, the value is under root 2 by a cos 2 pi x by a. Yes or
Nahi,
no?
this is cos pi x by a.
Above, sir, above this figure. For
This is sine
excited
2 pi
state.
x by, sorry, this is sine 2 pi x by a. Look at solution. First excited state is sine function.
Okay,
For
sir.
n is equal to 2, 4, 6, you will get sine function. For n is equal to 1, 3, 5, you will get cos function. अभी लिखवाया देखो आप पेज बदल कर देखो. And look at here, I have written here. The phi n is cos n pi x for n is equal to 135. So when you have odd number, you have cos function into this. But here, everything is sine. Are you getting this thing?
Yes, sir. Okay, sir. Thank you, sir.
Okay. If you have any doubt or you want to elaborate something, then you can just advise me.
सर
Yes.
सर वो दोनों ग्राफ रूट 2 बाई ए साइन 2 पाई एक्स पाई है ना, दोनों का दोनों केस में. तो
Yes,
वाला
दोनों केस में,
ग्राफ
हाँ.
मतलब हाँ वाला ग्राफ मतलब
यहाँ नीचे से आया यहाँ
वो
ऊपर से
मुझे
आया क्योंकि ऐसा फंक्शन होगा क्योंकि
गया वो
माइनस ए बाई
नीचे
2
गया
है. हाँ?
वो
यहाँ
मतलब
ऊपर
नीचे
नीचे गया.
से गया
आप
है.
प्लॉट करोगे जो है उससे क्या मतलब है? You will just plot it from 0 to a. That
अच्छा
will come
अच्छा
to like this.
ओके
Huh?
सर ओके सर ओके सर
Okay. Okay.
ओके सर.
So what you can see for the nth state, you have n minus 1 number of mode, isn't it? N minus 1 number of node. So for n is equal to 1, you have not any node. For n is equal to 2, you have one node. So you can tell all about this energy eigenvalue and so on. So this is all about a story. So I am just giving you final conclusion. So should I remove this? Okay.
Yes, sir.
Okay. So I hope that you people have get the answer. We have started. You have just started why we are doing this thing. Now suppose I will give you some potential, and this potential is between A to 2A, and this is infinite. What should be energy eigenvalue? What should be energy eigenvalue? The energy eigenvalue is E naught, 4 E naught, and so on. And what will be eigenfunction? The ground state will be something like this. First excited will be something like this. And now it may be different mathematical equation. It may be some complicated mathematical equation, but yes, it will be the ground state is symmetric about the center. And what is center? I think the center is 1.5a. So if you will calculate the expectation value of x, you will get 1.5a. So what should be the wave function? The wave function will come such that it will give you the expectation value is 1.5a, and they are symmetric for n is equal to 1, they are anti-symmetric for n is equal to 2. There may be different wave function other than sine and cos. Maybe it will be sine and cos with some phase factor. So this kind of situation can be there. Okay. So this is all about we have done in the particular. So I am writing the final version. What is the final version? The energy, sorry, if potential is going to, if potential is going to shift horizontally without changing the parameter, changing the width, that is much better, changing the width, then eigenvalue means energy eigenvalues and normalization constant will remain same, but eigenfunction will change such that it will even for n is equal to 1, 3, 5 and odd for n is equal to 2, 4, 6 with respect to center or expectation value of x. This is the whole story. This is the whole story. This is just one liner, and we can conclude this all about particle in box. So let's go for a next version of box. We will solve the problem together for every box, but right now we are just going for next story. Then this is not a infinite, rather it is just a finite potential. So if you have any doubt, you can ask me, otherwise we will go for the finite potential. So let's go for finite potential. So let's go for our next version of potential, that is finite potential. What is finite potential? We can write Vx is equal to V naught x is less than minus a by 2 and x is greater than a by 2 and 0 x is between minus a by 2 to plus a by 2. So this potential is something like this. And this is symmetric again about x is equal to 0. And we have to solve for the bound state. So what should be bound state? The energy, and this height is basically V naught. For bound state, energy is between 0 to V naught. And let's try to solve this. So again, this potential is symmetric. So parity must be conserved, isn't it? But what should be the solution of Schrodinger wave equation? So can anybody tell me what should be solution into this region? Region 3? First tell me region 3 because we have done this thing. What should be solution in the region 3?
Sir, A e to the power minus gamma x.
Very good, very good. तो इसको A नहीं कहते हैं. You will just take, चलो इसको कहते हैं E कहते हैं ना, E to the power minus gamma x. चलो what should be psi 1? अगर आप ये कह दिए तो psi 1 के बारे में बात करो. What should be psi 1?
A e to the power gamma x.
Very good, very good, good. A to the power gamma x. Because if you will solve the Schrodinger wave equation, you will get A to the power minus gamma x and gamma x. And you have to see that what will happen at x tends to infinity or minus infinity. So wave function must be decay at the minus infinity as well as it must be decay at the plus infinity. So actual solution will, look at, actual solution in the both region A e to the power gamma x, let leave gamma A and B, e to the power minus gamma x. So this will be relevant for this region and this will be relevant for this region because wave function must be exponentially decaying into these two regions. We have done this thing into step potential, remember? And what should be psi 2? Can anybody tell me what should be psi 2? What should be psi 2? Very
B to the
good.
power ikx plus C
So
to
we
the
will
minus
just write B e to the power ikx plus C e to the power minus ikx. So let's write this thing as something like D. Okay, something like D. और E भी रख सकते हो, कोई problem नहीं. So just use this thing as D. So this is the solution. So this is the first one, this is second one, this is third one. If you are not agreed with this, try to solve the differential equation and you will get this answer. We have solved it in the part, this thing in a step potential with the same logic we are using this thing. Now, again, our wave function must be even. So just today we will just solve the case for even. So what should be function? Same thing, psi 2 minus x is equal to psi 2x. What we are doing? Psi 2 minus x is equal to psi 2x. So what should be there? B e to the power minus ikx plus c e to the power ikx is equal to b e to the power ikx plus c e to the power minus ikx. What should be conclusion?
B equal to
What
C.
should be conclusion? B is equal to C. Conclusion is B is equal to C. So for B is equal to C, then psi2. So psi2 can be written as something B e to the power I kx plus e to the power minus I kx. So I can write this thing as cos function. So we can write this thing at d हो गया, इसको e कर लो, e cos function, cos kx, isn't it? So that should be e cos kx. यहां तक कोई प्रॉब्लम है तो आप पूछ सकते हो. Now we will just use the boundary condition, and now you can see in psi3 and psi1 both are some finite wave function, so our wave function must be continuous as well as differentiable, and hence it is symmetric. You can choose any one of the boundary, so we will use any boundary. I am just going to use this boundary. So let's try to do it. So up to that, everything is clear. Okay. So you have, so I am writing here so that I can use all this calculation. So psi1 is equal to, for the even case, psi1 is equal to a e to the power gamma x, psi2 is equal to e cos kx, and psi3 is equal to, what is this, d to the power minus gamma x. So this will be, x is between minus a by 2, and this will be minus a by 2 to a by 2, and this is x is greater than a by 2. Now let's try to use this thing. So you have psi2 at x is equal to a by 2 must be equal to psi3 at x is equal to a by 2. So from here you can write e cos k a by 2 must be equal to d e to the power minus gamma a by 2. Let's say this is equation 1. And second equation, we are just going to use that d psi 2 upon dx at x is equal to a by 2 must be equal to d psi 3 upon dx at x is equal to a by 2. So first we have to differentiate, then we will put the value. So when you will differentiate cos function, that will be minus k e sine k a by 2 must be equal to, now you have to differentiate it, that will be minus gamma d e to the power minus gamma a by 2. Now this is two function, and now we can just divide these two function. So when we will divide 2 divided by 1, what I will get? I will get tan k a by 2 must be equal to gamma. Isn't it? So e to the power minus gamma a by 2, e to the power minus gamma a by 2 will cancel, d will be cancelled. So we have this particular thing. So sorry, k is also there, no? So k is also there. So k is also there. K tan k by 2 is equal to gamma. Isn't it? Am I correct? So now what I am going to do, I will just make it dimensionless. What we will do, we will just make it dimensionless with the parameter. So this particular thing is dimensionless, k by 2. So I will just multiply with a by 2 on both sides. So what I will get? I will get k a by 2 tan k A by 2 is equal to gamma A by 2. So I have just multiplied A by 2, then I have made this all thing as dimensionless. Why we are making it dimensionless? Because we just want to work with a number, and once it will be work with a number, then it can be easily solvable. For the solution purpose, for easy calculation, it is very good thing that you can make it dimensionless, such that I can put gamma A by 2 is equal to eta and k A by 2 is equal to xi. So what will happen? This equation is known as eta is equal to xi tan xi. And now you also know what is value of k. Can anybody tell me what is value of k?
Under root 2m by h cut square.
Very good. Sorry. Good. Very good. So k is equal to root under 2m e upon h cut square. Can anybody tell me what is value of gamma?
So root under 2m v0 minus e by h cut square.
Very good. So that will be 2m v naught minus e upon h cut square. So we have done this thing. So this is the value of k and gamma. I am giving you homework that just try to figure it out. What is value of eta square plus xi square? Just try to get it all this number. Then we will use these two equation and we will try to figure it out. The solution, you can find the solution, the getting the solution or discussing the thing, we will discuss it from entirely different method that is known as graphical method. So only one system in a quantum mechanics can be fully solved, that is particle in box. Other system you have to use different method of calculation, different method of mathematics to solve it. So here we will use the graphical method. So next class I will discuss to how to use the graphical method to understand all this particular thing, and then we will go for odd function, and then we will one full class we will give the different type of problems based on potentials. Okay, so just try to derive it with yourself, and I am also giving you homework. Just try to do it for the odd function also. What should be this thing? Similarly, you will just go for. I will do it, but I will suggest that you can do it with yourself. Yes.
सर गामा इक्वल्स नीचे क्या लिखे हैं क्लियर नहीं दिख रहा है.
कल की क्लास किए थे?
यस सर.
तो बताओ गामा क्या होगा? स्टेप पोटेंशियल किया था?
यस सर. 2m v naught minus
क्या था गामा?
v naught minus e by h cut square.
बस सही है. ठीक है, अब लिख दे रहा हूँ. डोंट वरी. ठीक है, देखो कॉपी में क्या जा रहा है उससे मतलब नहीं है, दिमाग में क्या जा रहा है वो इंपॉर्टेंट है. तो अपने ऊपर कॉन्फिडेंस रखो ना. ठीक है, से यस या नो?
Yes sir.
Okay, good. So I will request you everybody that try to do it for odd potential, such that you can feel some difficulty, then you can raise the best question at that particular time when we will calculate it. First do it with yourself and then go for this thing. Please, these all derivation is very important. Derivation is very important because it will make it will clear your all concept. So please give little bit time for the derivation. Do it with yourself and then remember all the postulates. Next class we will just going to use the postulates and you will see how beautifully we have framed our postulates that we can understand each and everything very nicely. Okay, so next 2 and 3 day I am not with you, so maybe there is some rescheduling of your timetable, and I think I will meet you on Sunday, then continuously we will take this thing. Okay, thank you.
Thank you, sir.